Hi everyone, welcome to the Maths Statistics for A-Level Psychology session. My name's Anne Beckham and I'm presenting on behalf of Pearson Edexcel. I hope everyone has had a good day. So this evening we're doing a course of 90 minutes long, which would be a mixture of me leading you and hoping to inform you about maths and stats in A-Level Psychology, but there'll also be opportunity for sharing ideas and asking questions about the maths and statistical element in psychology. Hopefully you'll find it useful and make you more confident with the maths element. Okay, so just to go over the objectives of today's session, we are looking at improving your knowledge of the mathematical concepts which are in the content of the spec. We'll discuss teaching approaches to help students develop their mathematical skills. We'll take some time to look at specimen questions and mark schemes in order to help students interpret the questions accurately, and then address common issues and frequently asked questions. Okay, so like Antoinette said, you've received the copy of the PowerPoint and delegate booklet. There's a lot of information in here. So we will go through some of it and then you'll be able to access the parts that we aren't able to go through within today's session. Okay, so if we could start off just getting to know a little bit about who's with us today, by asking you to kind of rate your own confidence level with regards to maths and statistics element of psychology. Okay, thank you everyone. So that's good to know. So a lot of people sort of around the middle there of rating themselves sort of 3, 4 out of 5. So that's good. What I want to ask is, obviously you've joined today's training session, is what is the biggest challenge that you find when it comes to teaching maths and statistics? Yeah, thank you. So if you can just use the chat box, that would be really helpful, just to see what people's challenges are. Yeah, thank you. This is really useful to find out. So it seems a mixture of addressing students' lack of confidence when it comes to the statistics element. They can come without the GCSE or without a high grade in the GCSE and not be very confident themselves. And also some of you said sort of not being confident yourself. And you might find sort of bit of repetition with this question, but the last thing I just wanted to ask you is, what would you like to achieve out of the session? So some of you have sort of already covered that in your responses, and that's fine. Okay, yeah, great. So it's about addressing variability, increasing their confidence, and increasing your confidence as teachers as well when it comes to this element. And a couple of people have addressed in the chat box that it's sometimes getting over that barrier of making students realise, actually, yes, they can do the statistics element, and it's not as scary as it first looks. So we'll discuss kind of how it's presented in the exam with lots of exemplars, just so you've got those, whether it be a refresher or whether it to be used directly with the students. And then we'll look at some teaching ideas as well, and how to make it more accessible, make it maybe more enjoyable for the students who maybe dread this part of the course. Okay, so thank you for your feedback. So we'll get started. Starting off with kind of looking at the key mathematical concepts in the specification. So looking at where math skills appear, the types of questions, the content that students need to be aware of. So as you will be familiar, there's 3 exam papers for the A-level psychology, paper 1, 2 and 3, on 9PSO 1 or 2 and 3. And there's math skills required within all 3 papers. So we see it arise in the methods section of the topics. We see it in the practical investigations that they have to do in each of the first year topics, and then in clinical psychology in their optional unit in the paper 2. And then also the psychological skills section of 9PS03, which is the synoptic paper, which again can ask them any of the maths or statistical elements of the course. So in summary, it can be asked in relation to their own practical investigations that they have carried out, but it can also be given to them with hypothetical scenarios. So there's maths in all 3 of the papers. How math skills are assessed. So a lot of them are short answer questions. So this could include descriptive statistics and inferential statistics, and we'll highlight and remind you of the difference between the 2 this evening. It's at least level 2 mathematical skills, and a minimum of 10% of the qualification will be based on maths and statistics. Okay, so if I just link to the specification. That's what I want. As we go through, I know a lot of you will be familiar with this. Through the different sections, we can see that it talks us through, sorry, a bit further than thought, talks us through social psychology, and then midway there's a section which has methods within it, and then as a breakdown of the methods section, we see where the maths and the statistics comes into each section. So I expect that most people would teach these parts embedded within, for example, social psychology. This is in each section. So you can see when you get to cognitive psychology, it's quite a big page full of research methods related, and then the analysis of data, and a good sort of thorough list of what students could be asked and are expected to do. Okay. The same is for biological and learning, that you have those sections in there as well. And then when it gets to clinical psychology, Similarly, you have the practical investigation, but you also have a methods section, and that will highlight what they might be asked within that section of the paper. And then that's repeated in the topics, whether you do crime, child, or health as your optional topic. And topic 9, psychological skills. This is a nice place to access summary of everything. But there's a list of methods, and we're going to be looking at this today. The descriptive stats and the inferential stats are all listed there as well. So it's a good starting point to ensure that everything is covered. Okay, and I think the link for that is in the chat as well. Okay, so just having a look at some of the questions and then corresponding mark schemes that might be asked. There's a copy of this at the start of your delegate booklet, where this lists all the descriptive statistics that students can be asked about. So measures of central tendency, so students could be asked to calculate a mean, mode, median. We've seen frequency tables, 3 different types of graphs, normal and skewed distribution, sense checking data, and measures of dispersion. And then also be able to kind of understand and interpret what those means mean. So being able to compare the means, compare the standard deviations. In terms of any formulas that they need, so for example, standard deviation, that's at the front of each of the exam paper. So they're not expected to remember the formula, but they are expected to be able to know how to use that formula when carrying out the calculations. So measures of central tendency, this could be mean, mode, median. We can also see some descriptive stats which include percentage, ratio and fraction, such as the question which is page 2 of your booklet. Oh no, sorry, beg your pardon, it's not in the booklet, sorry, it's on the screen in front of you. So you can see this is a past question where they've given a scenario of 3, what initially might look like straightforward calculations for the students. 1 asking for the percentage, 1 asking for the ratio, and 1 asking for the fraction. So even though GCSE maths might be a bit of a prerequisite for some people who study in A-level, so I know some places of study will ask for them to have the GCSE maths in a certain grade, it's still important to embed these skills into the teaching. Common errors that we see are students maybe not being accurate, but other errors we see not putting the fraction in the lowest form when it is clearly asked for that, getting the ratio the wrong way around, and then where applicable, decimal places, not doing it to the right number of decimal places. So even though this might appear kind of the easier part of the maths element of the course, it's really about reinforcing their skills. Not all students, like we've said, are very confident with their maths. And so it's making sure that they understand that they've paid attention to the question and that they understand the difference between ratio, fraction, and what that means. Okay, so I'll just pause there in case anyone's got any question. We're going to have a look at graphs next, but just in case anyone's got any questions about these kind of straightforward maths questions that they can be asked. Okay, seems maybe no one has any questions, so we'll move on. If you do, feel free to put them in the chat and we can address them a bit later. So looking at graphs. So the graphs element of the specification is that they need to be able to produce 3 types of graphs. The most common one that we see being asked is to draw a bar chart. So here we've been given a scenario, and then there is a question to draw a bar chart, and it's worth 3 marks. So I put, there is a copy of this one in your booklet if you've got that in front of you. What I'd really like us to kind of just remind ourselves is how we get those 3 marks. So if you can remember how to get the 3 marks, if you pop it in the chat. Yeah, thank you to those who have responded. The title, the axes, and plotting the correct data. So just have a look at the information on the screen, and if you could, have a go at drawing the graph just quickly, and then we'll just reiterate how those marks are awarded. I hope everyone's having a go at drawing the graph. The feedback from examiners' reports is that some students know how to draw a graph, and some students are still losing marks on these graphs. So again, it's about confidence in students and them knowing how the marks are awarded and how specific they need to be. Okay, hopefully I've been long enough just to think about at least, or draw out your graph. So here's what your graph should look like. So just to go over the 3 marks, how students are going to be awarded the 3 marks here is 1 mark for the correct title. So it gives an example there. It needs to be quite operationalised. It can't just be a bar chart to show the data, a bar chart to show the results that the participants gave. We need it to be quite specific. Just to kind of throw in how I sometimes instruct students personally to do it is where they have the instruction at the top here, draw a bar chart to show the number of participants with high scores, etc. I get them to use that, and that is essentially their title. Then the draw this way. They get a 2nd mark for the labelling of the axes. So this has to be really carefully and clearly done. It's not enough just to put condition A and condition B. It needs to be clearly labelled, both axes, starting at 0, going up in equalised points on the left axis. And then the 3rd point needs to be accurate plotting. So that needs to be getting the numbers right. So again, we see students just get them back to front. It needs to be the data they asked. So students in this question, if they haven't read it carefully and they've just seen there's 4 bits of data there in the table and plotted all 4, they're going to lose the mark here. And also if they haven't left a gap between the bars, they'll lose a mark. So what might appear as quite a straightforward question to draw a bar chart can actually be quite challenging for students if they don't pay attention to the detail. The second type of graph they might be asked to draw is a histogram. So this is a bit more rare when you look at the past papers. It hasn't been on as much. The key difference between our bar chart and histogram for psychology is that there's no gaps between the bars. And also when it comes to a histogram, each bar represents a range of values, with the height showing how many data points fall within that range. So the title's the same, we need it detailed, operationalised. And then labelled axes just as clearly, with the numbers on the label. And then the third type of graph that they can and have been asked is a scatter diagram. And again, it's the same 3 marks, so it's really training students to know about the titles, the labels, and accurate plotting. We don't need a line of best fit. And either way round, so if in this example they put exam score on the bottom, number of missed classes on the side, that would be acceptable. Okay, so I can see we've got a couple of questions in the chat box. So no, they don't need to be equal width. The histogram, I'll just go back to the histogram. Yeah, the histogram is talking about how much data falls within specific ranges. So whereas in a bar chart, you've got distinct categorical data, here you've got range. So like an example on the screen, how many remembered between 0 and 5 words? How many remembered between 6 and 10? So you've got sort of the range along the bottom and the frequency at the left-hand side. Yeah, so the x-axis is the horizontal one. I like that, Y to the sky. Thanks, Jessica. And the y-axis at the side, so you would have the frequency on the y-axis. And then you would have the range on the bottom. So the height of the bars is showing the frequency, how many was in that range. What would the conclusion be for this particular graph? So, you know, one conclusion might be that the majority of students record at least 6 words in this example. or you could pick out a more specific conclusion and say the most common range of words recalled by participants was 6 to 10 words. Any other questions, or anyone else want any more clarification? Okay, move on. So sketch diagrams. So moving on to the next bit, is talking about standard deviation. So just to remind you that students don't need to remember this formula. This is provided for them at the front of the exam paper, and the formula on the screen is how it's presented to them at the front of the exam paper. In the A-level paper, there's no scaffolded table for them like we see for some of the stat tests later on. They're given this formula, they're given some data, and they're asked to calculate the standard deviation. So they really need to know how to use this formula. And in my sort of opinion, that's what can make the standard deviation a little bit trickier for them to calculate, because it doesn't have those first couple of steps scaffolded like we see in the stats tests. I tend to teach students this in 6 steps. What would be the first step that you tell students that they need to do? Anyone want to sort of add what they would want to do? Yeah. So thanks, Jessica. Yeah, so taking the mean from each individual score. Not sure what your second comment is. Not sure if I've misunderstood that. This is an example of how we see it in the exam. And they can use calculators. Advise them to use calculators. And I'll come back to it shortly, but it's different to how, well, it's partially different to how they might be asked to calculate standard deviation within maths, which can be an issue when you've got some maths students in your class who highlight to you, well, we don't do it like this in maths, or it's different in maths. So it's worth just knowing the difference. It's quite a straightforward difference, which I'll go into shortly. But in terms of when I teach them 6 steps, I always say you calculate the mean first. So if anything that students need to remember is when you're doing standard deviation, the first thing you need to do is calculate the mean. And then each score minus the mean. And square each one of those. So that's sort of the bulk of the work, and they have to remember to do that separately. By that I mean kind of each score minus the mean, rather than see some of the variations of what they do. Once they've got those first 3 steps done, they can then total up those squared results, divide by n minus 1, and then find the square root. You could use a scaffolded table, so where they put the score, and sort of, or they'll already have the score written for them in in their exam paper, and then them get used to minus the mean from that, then square each one, and then do the last 3 steps where they total it, divide, and find the square root. Okay, so if you want to have a go at completing that, I'll just read back those last couple of questions. If you want to have a go at calculating the standard deviation, I've left sort of my guidance on there. If you want just the formula, that's in the front of the exam paper. If you want to put your answer in the chat box when you've got it, I'd also be interested to know whether you did it on a scientific calculator, if you brought one, if you have one to hand, or whether you did it a long way, whether you teach it differently. Alongside your answer, if you've got any feedback about how you teach students to do it, do you teach them to do it on a calculator, or do you teach them the steps like I do? What are your responses coming in? Thanks, Jo, for your response. If people haven't had a chance to do it, maybe not had access to a calculator at this point, is anyone able to share how they teach standard deviation, whether you do it using a calculator, teaching them how to do it on the scientific calculator, whether you do it in steps, whether you've got any other ideas? Yeah, so if you've got students who are competent in maths or studying core maths A level, they can do it on a calculator, and it's really straightforward for them. And yeah, it just saves so much time. I say to students, really, you should be in the exam. You just want to spend about 5 minutes on this, but it's actually quite a lot of work to do in those 5 minutes, depending on your data and how much data you have to calculate. Okay, just to show you the answer, in case anyone wants to check, but also so you know where the marks are awarded. To get the first mark is the hardest, sort of the more work. They get the first mark for taking away the mean from each score. So they've had to calculate the mean and take it from the score before they can get any credit. And then hopefully they've done that accurately. So calculate that, and that gives them a total of 23.2. They need to divide that by number of participants minus 1. So in this case, there are 5 participants, so they're going to divide it by 4, which gives them the sum of 5.8. And then they calculate the square root. The question does specify to give their answer to 2 decimal places. It's a 2.41, which would get them the 4 marks. Yeah, so it's hard to exactly say, but if they've asked for 2 decimal places, they need the final answer to 2 decimal places, and the students risk losing a mark, which is sort of why I emphasise to them, show your working out, show your calculations. Even if you've done it on a scientific calculator, sometimes note it down, because one small error on by doing it by hand and showing your workings, it sometimes might just cost you 1 mark. But if you make one small error and you've done it on the calculator and you come up with the final 1 mark, if they can't see your calculations, then they risk losing 4 marks. No, they'd be expected to do 2.41. So if they give the answer to 2 decimal places without showing any workings, it's correct. No, they will get full marks. Sorry, yeah, they'll get full marks for a correct answer. My issue is, say, if they put 2.31 at the end and hadn't showed that actually they'd calculated it correctly up until that last step, they won't get any marks. So it's really important to say to students, unless you're really confident, then you either want to double check it using your calculator, or you want to show your workings. They usually do, yeah. We usually see it being asked to 2 decimal places, sometimes 1 or 3. So again, it's reading the question. If it doesn't specify, then they can't be penalised for not doing it to the decimal places that they've specified it to. So if they just say, calculate the standard deviation, and they put the full answer, that would be acceptable, because they haven't specified for it to be done to a certain amount of significant figures or decimal places. So just some things to look out for. We've already talked about the use of the calculator. It's different, and I think someone, thank you, highlight this in the chat, so it's different to how they do it in A-level maths, which confuses some of them a little bit at first. Mathematicians, they divide it by n, population, whereas in psychology, we're doing it as a sample, so we do n-1. And that's the difference, and they can use their calculator still to do that. It's just a different function button, I believe, on it, where if they're using a calculator, that makes it possible, but it is highlighted to them. Don't go into confidence mode of doing it how you do in maths, because it's a bit different. We've already mentioned about reminding students to check their decimal places. They also need to understand what standard deviation means. So we've seen this in recent papers where they've been asked to compare standard deviations. And what does that actually tell us about the results? So they need to understand about kind of how much the scores are spread from the mean. And the smaller the standard deviation, the smaller the spread and the closer to the mean results were. Whereas if it's a larger standard deviation, then they're more spread out from the mean. And students need to be able to interpret that. Okay, so we will move on. Please keep the questions coming if you've got them, so that you're really clear on everything here that we're going through. Start to have a look at inferential statistics. So again, this is can be quite challenging for some students. A lot of it, I think, like we highlighted at the beginning, is confidence with the students believing that they can do it. There's a list there which is also printed out for you in the booklet, or put in the booklet for you. There's a list there of everything which they are expected to know. Again, inferential statistics can come up on any paper. We've seen them across the three papers previously. So it's just preparing students for that. And just because it comes up on paper 1 wouldn't necessarily mean it doesn't, the exact thing doesn't come up again on paper 2 or paper 3. So decision making and interpretation of using stats. This includes level of measurement. So they need to know their different levels of measurement. How to choose a statistical test. So when we choose Mann-Whitney, Wilcox and Spearman's chi-square. How to use the critical value tables. And then levels of significance. And within that, we see about accepting and rejecting hypotheses, type 1 and type 2 errors, and the relationship between significance levels and p-values, probability values, and observed and critical values. So it's important when you are teaching these two students that you use the terminology, so it familiarises them with terms like critical values, observed values. Again, formulas are given at the front of each exam paper. The statistics we'll go through, and the statistical tests, sorry, are scaffolded to a certain degree. So there are marks given for partially correct answers again. And we see at least one statistical test per exam series. So the purpose of statistical tests is to help students decide if results are significant or not. So they need to understand about significance, probability, the different levels of significance. And initially, I imagine most people will introduce this when they've done their own practical research. So when they have to do a statistical test and find out if their results are significant or not, and use the critical value tables there. But also, like I said before, they could be given hypothetical research. So in relation to a scenario, for example. Types of questions they can ask. Again, short answer questions, identifying or stating level of data. So being able to recognise what nominal level data is, ordinal level, interval level. Being able to choose which stat test should be used, or be able to justify why a specific one was used. Analyse the results that either they found or that have been given to them in the paper. So be able to draw conclusions and how that affects whether we accept or reject hypotheses. And then being able to discuss significance levels and type 1, 2 errors. Okay, I'm just going to pause there while I just look back at some questions. Sorry, Kate, is that sufficient space in the booklet for you to take notes? Don't forget you've got, I think I'm right in saying this, you've got access to the PowerPoint as well, where you've got these written down for you. And there's a bit of space on the back as well if you needed to make any notes or anything. Yes, Imran, you're correct. So in paper 1 is specific. So if you look at the spec, like you say, they're not expected to know any of the statistical tests, so they won't be assessed in the social section on any of the SAT tests. We see standard deviation there and the other descriptive stats. Cognitive is Mann-Whitney and Wilcoxon. Yeah, they're assessed in the cognitive section. Spearman's biological chi-square and learning theories, that's right, yeah. Paper 2 and paper 3, we could see any of the stats at any point in the paper. Okay, I'm conscious of time and we're just over halfway through the training. In the presentation for you, I was going to show you kind of how each of the stats tests are presented. I don't think we've got time. You might be thankful to do the maths unless anyone specifically wants to have a go themselves. But you will see that in the PowerPoint as well as the answers to those questions. I put an example question in here of when students and what circumstances they might be asked to choose the appropriate statistical test. So it gives a scenario, and this is a skill where a student has to pick out what level of data, what design, is it looking for a correlation or difference, and then put that knowledge together then to be able to work out which test they use. So here, explain which stat test Ken would use for his data. He's getting a mark for sort of identifying which stat test would be used, and then the second mark for explaining why. And we want to see that being related to the scenario. So anyone offer me which stat test you think Ken should be using? Yeah, thanks, Joe. You were quick there. Wilcoxon. So this requires students to pick out why is it Wilcoxon, and they need to probably give a couple of reasons why. So here they would need to talk about the fact that Ken is looking for a difference and he has used repeated measures. But to get the marks, remember, we want to see that not just as pre-learned information, but repeated measures because students, participants are asked in the morning and then again in the afternoon. So it's really exemplified linking back to the scenario. Okay, so quick question there. Would you like to go over which test is used when? There is a copy in your booklet and it's on the next screen as well. Okay, so got a couple of no's. It's there for you. I've put in bold kind of what makes them stand out differently to the other tests. So we will skip over that, but you've got that as a reference. We'll talk about how you can get students to learn that. Following on, the next few slides are how they're presented in the exam. And so what I kind of remind the students is that when they do the practical, they do it right from scratch, and that's the hardest they'll ever have to do it. When they do the stat test in the exam, actually it's quite scaffolded. So for example, in chi-square, it's a case of following the table, and that makes the marks a little bit more accessible. Things to watch out for is the question asking for how many decimal places. So there's two examples on the screen where one asks for your answer to 2 decimal places, and the other one says you must give all your answers to 1 decimal place. So again, directing students really read the question carefully, because it often, not always, but often will direct you how many decimal places they want. The other thing to watch out for, sorry about the misleading statement there, is squaring the final answer again. So what I find that a lot of students do is they will do the calculation O minus E and square it and divide by E and total it. And then because it says again chi-square, and they see the symbol and it's squared, they square it again. So again, it's just something to look out for. There's no error carried forward in the statistical tests. So chi-square, put that first. I think it's the more accessible for students. They don't, even though they're given a formula at the front of the exam paper, in my opinion, they don't need to refer to that formula to be able to carry this out successfully, because the instructions are quite clear on the top of the table. O minus E, they've just got a column saying observed and one saying expected. So there's your O and your E, and then square it, divide that by E and total it. And that's where the 4 marks come from. Sometimes they will be asked, like on the left-hand example, to determine whether there's a significant difference. So they will have to use the information they've collected. That's where, oh, thanks, Joe, thank you. That's where we'll see that if they have made an error in their chi-square, this is about testing their skill. So if they have got the answer on the chi-square, usually that error will be carried forward here. It's a good question, Kate. There's nothing, I don't believe anyway, that specifies it will always be a 2 by 2 table. Nothing saying it always will be. We haven't seen anything other than that, but I don't think I can guarantee that we couldn't do, which is something I think might throw students a little bit when it comes to calculating the degrees of freedom and working out the significance levels. Okay. Any more questions about chi-square? The answers are on the slide for anyone who wants to have a go, or use these with the students for them to have a go and talk through. Moving on to specimens then. Here they're given the formula. This is partially scaffolded. So by that what I mean is you can see from the way it's laid out, the first two columns, the D and the D squared, it's kind of a reminder these are the first two steps students need to take. This might trip students up. The difference is between rank 1 and rank 2. So we want to see them rank 1 minus rank 2. Tell them to stick a pen to cover up the middle column to not get confused if they need to. And then they square that. So for example, in the first row, 1 minus 1.5, 0.5, and then they square that to get 0.25. And they do it all that way down and they total it. So students can get 2 marks just for completion of that table accurately. The other 2 marks come from then using the formula. So essentially what they've just calculated there when they've totaled up the D2 column is the total of D2. So we can see how that fits into the formula. And they just need to times that total by 6. 6 times the total of D squared. And divide it by times n squared, take away 1. Again, where n is the number of paired scores. And then take their final answer of that away from 1, which again, I don't know if some of you have the same experience with students, is often forgotten. They'll work out, and yeah, I've done the division, and forget that they have to do 1 minus whatever they've found. So in this example on the board, 1 mark for correctly completing the D column, then squaring it and totaling those squared numbers for the 2nd mark. Substitute into the equations. This is again where students benefit from showing some workings out, because if they put it into the equation correctly, even if they get the final answer wrong or they haven't done it to the right decimal points, they can still get 3 out of 4. They've just showed what they intended to do. Please at any point ask any questions. I'm aware kind of time, so I'm going through things quite rapidly. But if at any point you have a question, I know a lot of you are saying it's about increasing your confidence as well as the students' confidence, then please do ask. Thanks, Jessica. So there has been asked question 3 by 2. My mistake, I didn't think we had previously, so thank you for clarifying that. The third stat test they can get asked by is Mann-Whitney. So here they can get a mark for just calculating the totals, and then they have to use the formulas. So the formulas are given to them at the front of the exam booklet. Just trying to get to that. So the front here, we've got the Mann-Whitney formula there. They have to calculate UA and UB, and then they'll put an answer down for U as well, which is the smaller of UA and UB. Again, how I teach this is in 3 parts for each formula. So teach them to do the NA times NB. That's the first part. So N being the number of participants, and we'll talk about A as in condition A, so the number of participants in condition A, times by the number of participants in condition B. And then the second part of the formula is where they do Na and then bracketed Na plus 1 divided by 2. And then the third part of the formula is the total of rank A. So when they've got those three numbers, it's a case of adding two together and then minusing the total of rank A. Then they do the same for UB. Now, quite often, but again, there's no guarantee, the number of participants in condition 1 and the number of participants in condition 2 may be the same. So 2/3 of the formula would be the same, and it's just that last bit that's different. But again, there's no guarantee for that, and you might be able to recall when they haven't done that. To show how that looks kind of in practice there. So they get 1 mark for identifying the totals of the ranks. Second mark for incorporating it into the formula. And then they'll get the marks for the accurate UA and UB. And then the last stat test is the Wilcoxon. So there is no formula for Wilcoxon. What we do see for Wilcoxon instead are the directed instructions. So students need to be reminded that they have got reminders here how to complete it. Some of your students might just like to do it and remember kind of through the headings of the boxes what they need to do. But there is a reminder there of things like don't rank any differences of 0, ignore the signs when calculating the difference. So what we're asking students to do here is, first of all, calculate the difference between condition A and condition B. So literally condition A minus condition B. So 1 minus 5 is minus 4. And do all the difference column. Then they need to rank those. So that is another skill that you will need to teach them about ignoring the 0 when they're ranking and ranking them from the lowest number being rank 1 upwards, ignoring the signs. So in the difference column, they have to ignore the signs there for this step. And then what they do with the last two columns, if in the difference column, it is a positive number, such as if we have a look at the example here, in the difference column, we've got a positive number of 2 on row F. They transfer the rank into the rank if positive column. If it's a minus number in the difference column, so we see most of them are minuses there on the screen, you transfer its rank into the end column and then total up the two columns. And that's the 4 stat tests. And it's familiarising them with the stat tests, lots of practice, getting them to see how it's laid out in the exam. And I think it's a lot more accessible than sometimes how they have to do it from scratch otherwise. So I'll just pause. Any questions? Yeah, I know what you mean about the heading of the columns. We kind of need to know how to what that means. So I sort of teach mine. You put its rank in here if it's positive in the difference column. You put its rank if it's negative. And really reminding them that it's the rank that gets transferred, not the difference. There's a little bit here on interpreting results. So a skill that we see, again, I can't say they're going to put it in every year, but we see it in quite often in the papers where they're asked to use the observed and the calculated value, compare that to the critical value, and then say what that means regarding the findings. So this is a skill where, for example, in the question on the screen, they're very much specified in the question that they're what the calculated value was, so 1.27, whether it's directional or non-directional. So in this case, it's directional, and that they want them to use the 5% of low significance, and the DF is 1. So actually in those couple of sentences, they give the students all the information they need. Then they just have to use the critical value table at the front of the exam paper to say, you know, is that significant or not, and justify why they think it's significant or not. So they'll get the first mark for comparing the calculated value, which is 1.27, to the critical value. So in this case, the critical value is 2.71. So they'll get the first mark saying the calculated value is less than the critical value. And then they'll get the second mark for saying, what does that actually mean? So in this case, for chi-square, it means there's no significant difference between helping behaviour of the males and females in the study. So there's explain to markers, and just like you would teach with any other explain questions here, they get the first mark for kind of explaining it, the conclusion. And there's another question that's testing them on the same skill, but in a different way. So this is a part B. So obviously they'll have been given the information part A and used the calculated value, but this is getting them to use the tables to pick out the lowest level of significance that could be used with regards to this result. And that was, if anyone wants to have a look at that one, that was the 2021 paper, paper 1. So again, 1 mark for the lowest level of significance. So in this case, it was 0.025. And then justifying why that was the lowest level of significance. So referring to the calculated value and comparing that to the critical value. So it's quite a structured response. It's a skill that just needs practicing with the students. It can be done quite regularly and only take 5 minutes just to keep practicing it. Okay, that leads us to kind of the end of the stat tests. I'm aware we haven't had time to go through them all, and you might be thankful not had time for you to complete them. But does anyone have any questions or confusion about how the questions are asked or what the students are expected to do in terms of the stat tests? Okay, well, I hope that's helped. Hope you found that useful, just as a refresher for some of you, a reminder of how the stat tests are laid out, and a bit of clarification if this is new to you. The other kind of element of what we thought would be useful to cover today is how stats is taught. So how we increase confidence, how we increase the skills that our students have. Put a list together of ideas, and then I'll probably ask you if you've got any that you can share, because that would be really, really helpful. So there's some ideas here, some of which I'm sure you'll do and you can build upon and things. First one, just using the practicals. So a lot of the math skills, the descriptive stats, the inferential stats, the drawing graphs, justifying which test, determine if it's significant or not. A lot of that we see when we do the practicals. So that makes it really nice because they can contextualise, they've got something to relate it to. And it's built in, and you might get them to write it up. So that's good practice for them. Another teaching idea is to just make up scenarios. So you can use ones, there's lots that are on past questions, but you can also make them up. I mean, AI would help you be able to do this in terms of make them interesting, make them funny, personalise them to people in your class, do short, quick, practical experiments in class. You know, ask them how much sleep they got the night before and ask them how happy they feel. So you're addressing well-being there as well, and then do a correlation on it. So there's lots of ways in which you can just do a quick, fun, made-up research, or actually doing a quick bit of data gathering and then analyse the data. You can ask them which test would they use. Shall we ever go analysing it? Let's compare your standard deviation to the standard deviation I got from the other group. So you could make it a bit fun for students. Scaffolded tables, so just reminding them to use the tables that's given them in the exam, but also think about, you know, they could almost produce their own scaffolded table for the first part of standard deviation to help them remember and to keep them organised in the exam, what they need to do. Teach a partner how to do it, so working in pairs or working individually, give them a different stat test, get them to work through it, get them to increase their own confidence in it. So a bit of differentiation, you can give what you might perceive as the easier stat tests to the students who are less confident, and then get them to teach a partner how to do it. Again, it's just an alternate way. I'm sure you do this or similar with other teaching methods of teaching each other. Not only are they listening to someone else explain how to do it other than yourselves, but also they're teaching someone else how to do it. So that helps their learning as well and consolidate their understanding. Past questions, just use them as starters. Plenaries, you could make it competitive, do them as team quiz, do them as a race if you feel your class are up to that. And then I know this session wasn't about methods as a whole, and it's more about stats and maths, but just put a few suggestions there on teaching the methods content. So sometimes it can be a little bit dry, but there's lots of activities like sampling with skittles. Surprised how excited and into different sampling techniques students can be if you introduce different coloured skittles and tell them they can eat them at the end, or doing experiments with chocolate to illustrate repeated measures versus independent measures. Using their height, using how fast they travelled to college that day. All of these just to try and make it a little bit more fun, a little bit more engaging for the students to increase their confidence. Sometimes think if they enjoy it a bit more, they'll be a little bit more confident as well. And lots of kind of I do, we do, you do, that idea of, right, I'm going to show you how we calculate this stat test, then we'll do one together, then have a go individually. So you're building up their confidence gradually as well. Another one, haven't put it on the list there, but it just came up, choosing stat test. I get them to do an acronym. So for example, chi-square is used when it's independent measures, nominal level data, and looking for a difference. And then I might say that spells out the word kind with a C, make a sentence with that, or just remember these terms. And I always feel a bit silly doing it, but there's always some students who that works for them. That helps them remember it. So I'd quite like it if I could open up the floor to you guys and see if you have any ideas you could share of how you teach it, how to make it more enjoyable, clearer for students. There's space at the back of the booklet if anyone wants to write down other suggestions. So anyone mind sharing any ideas? What I do find is if students feel well prepared for the stats, they've practiced the stats. Actually, I was finding some students were looking forward to the stats element on the exam paper this year who maybe hadn't been looking forward to it earlier in the year, just because they know that's probably 4 marks on a stat test that they can get because they felt so that they practiced it so much. Yeah, thanks, Annie. So you're saying do class research and have a test of the day, incorporate that into lessons and into the practicals. Yeah, fair. Some of our students just need to know that they can do it in kind of the safe non-test environment first and build up their confidence. And again, I reiterate to students, don't just see stat test or the word standard deviation and think I can't do it and turn over. But I do say, no, try and get some marks. If you really kind of can't get your head around it later on, at least just have a go at a couple of steps and get a couple of marks there. Yeah, thanks, Laura, for your question about chi-square. So this came up earlier and I thought I identified that it's usually 2 by 2. So the degree of freedom being 1. But someone else had said there was a 3 by 2 previously. And I think in a past question where they give you the result and they ask you to determine the significance, there has been an occasion where they've said where the DF is and it's not been 1. But I don't know whether that's been the case for whether students have had to calculate it. Yeah, with a DF of 17, thank you, yeah. So I don't think they'd had to do the chi-square itself for that, although I might be wrong. But I think it was one where they'd been asked about the interpretation, so to determine if it's significant or not. Yeah. Yes, yeah, so just reading off. And they can be expected to do that. Giving the information. What we didn't address earlier on when it comes to just thinking about critical value tables is when it comes to Mann-Whitney, is just highlighting the difference to students between the 4 tables that are given at the front of the exam paper. So I'm sure you're all aware, but just in case there's anyone who is not so familiar with this, under Mann-Whitney, there's the first test, and we can see that this is when it's a 1-tailed 0.05 significance level or 2-tailed 0.1, and then that differs when it comes to the second one in there. So it's 0.01 for 1-tailed and 0.02 for 2-tailed, and there's four different ones there. So just something to highlight to the students. It's all the same in terms of at the end, it tells you about the calculated value must be equal or less than critical value for any of the Mann-Whitney tests, but just something to point out to students. Okay. So thank you to those of you who have inputted and shared your ideas, for your asking questions. as well. I think we've covered everything that's on those common issues there. So just to draw your attention to these last few slides, we've had a look at the concepts in the specification, identified some teaching approaches and shared some ideas, looked at specimen questions and mark schemes, which I think are essential for you to familiarise yourselves, but also for us to use with the students. And then had a look at kind of what the common issues are throughout that. There is, some of you will be familiar with Tim Lawrence, who is psychology subject advisor. And so there's his contact details on there in the PowerPoint, both email and phone number. Also, if you haven't already, there are regular updates. I think actually the latest update maybe just got sent out this week with relevant information about A-level psychology. So sign up if you haven't, because that can be really useful and informative. And then just to highlight and make you aware of this fantastic resource that's been put together based on using maths in psychology. So it's been developed, there's already a few resources on there today where it's given math support. When you look at these resources, there's instructions, there's past questions, there's answers, and it's quite thorough. You can see there on the screen there's worksheets on histograms, probability and significant figures that you can use with your students. So that's going to be built up, and I think that's going to be added to one a month, and it's looking at a bunch of 10 worksheets. And that's the idea, where it talks the students through. Thank you. The links in the chat box for you as well, but it talks the students through an exemplar, gives exam style questions, gives them answers, and they're all free resources for you to use. There's also existing maths and science resources that might be helpful as well. There'll be an overlap there. So you've got the information there on the screen and link for you for that. Okay, there on the Pearson's Professional Development Academy page, you will find access to previous recordings. So you can access that via Pearson. And just to inform you that following this event, you will have an invitation to share your thoughts about the session, which are always invaluable, because then we can see whether it's tailored to your needs and where we could do better with this as well, or help you in other areas. Okay. So I'd just like to say thank you very much for joining us this evening and giving up your time. And from myself and from Pearson, thank you.